Okay, symmetry. The next theorem uses the substitution rule for definite integrals. 5. To simplify the calculation of integrals of functions that possess symmetry properties. Theorem 6. Integrals of symmetric functions. Suppose f is continuous on the closed interval from negative a to a. For part A, if f is even, meaning f of negative x is equal to f of x, then the integral that goes from negative a to a of f of x dx is equal to 2 going from 0 to a f of x dx. If f is odd, meaning f of negative x is equal to negative f of x, then the integral from negative a to a f of x dx is equal to 0. Now let's take a look at the proof. Now we split the integral in two. So if we have negative a to a f of x dx, this means it's going to go from negative a to 0 f of x dx plus from 0 to a f of x dx. So here, if we want to rewrite this so that the lower limit is 0 and the upper limit is negative a, we can then rewrite this so it's negative 0 to negative a f of x dx plus 0 to a f of x dx. So in the first integral on the far right side, we make the substitution where u is equal to negative x. Then du is equal to negative dx, and when x is equal to negative a, u is equal to a. So therefore we'd have the following. So negative 0 to negative a f of x dx becomes negative 0 to a f of negative u times negative du, which then equals 0 to a f of negative u du. And so the equation 7 becomes the following. So from negative a to a f of x dx is going to equal 0 to a f of negative u du plus 0 to a f of x dx. Now, in part A, if the function f is even, then that means f of negative u is equal to f of u. So equation 8 would give us the following. We would have 0 to a f of u du plus 0 to a f of x dx, which means when you add those together, it's going to give us 2 of those. So that means you have the area on this side and the area on that side, which then is going to give us 2. Now, if the function is odd, then f of negative u is equal to negative f of u, and so the equation 8 is going to give us the following. This is going to be negative, this is going to be positive, and when you add the negative with the positive area, it's going to give us 0. So that means if you're adding this negative area with this positive area, it's going to give us 0. So, Theorem 6 is illustrated by those figures above. So again, for the case of where f is positive and even, part A says that the area under y is equal to f of x from negative a to a is twice the area from 0 to a because of symmetry. And recall that an integral can be expressed as the area above the x-axis and below y is equal to f of x minus the area below the x-axis and above the curve. Thus, part B says the integral is 0 because the areas would cancel each other out.